So now we're covering section 17, variations on random sampling, and this is in the textbook Making Sense of Statistics. So section 3 noted that a population consists of all members of the group of interest to a researcher. And we also discussed earlier that the population could be small, such as all social workers employed by a public hospital in Detroit. Let's just say that's 20. Or it could be large, such as all social workers in Michigan, which could be around 240,000. The larger the population, the more likely the researcher will study only a sample of the population and infer that what is true of the sample is also true of the population. That is called generalizing. So the process of making such an inference is referred to as generalizing from the sample to the population. Now, this is also when a researcher infers what is true of the samples, true of the population. The researcher is generalizing from the sample to a population. As you can see, I stated that 3 times. Could you ascertain that this is something important that I would like you to know? Yes. So let's look at freedom from bias. It is the most important characteristic of a sample. An unbiased sample, all individuals in the population have an equal chance of being included as a participant. There are no favorites. You cannot have favorites. Now, the simple random sampling is the basic method for obtaining an unbiased sample. And this is a lot of times we think of random sampling where you can just put names on slips of paper and draw the number needed for the sample. Now, this method is very efficient for drawing samples from small populations. So if we did a small random sample, we might use a table of random numbers, then to write names on slips of paper. But let's look at, we're doing names from a hat. So as you see, we have selected these people, and all of them have been selected with a name from a hat. Now you can see there's John and James and Jude and Jess, Jared, Julie, Jordan, Jalen, Joan, and Jose. Also, you need to see that while this is efficient for drawing samples from small populations, sometimes you may not have a very representative sample. Let's go a table of random numbers. We might select someone by their number name. In the table, there's no sequence to the number, so we can assign everyone in the population a number name. So if there are 90 individuals in the population, we can name each one 01, 02, 03 until we get people who are 90. So then we also would just draw the numbers that are assigned to the name. There again, table of random numbers, simple random sample. Now let's look at a stratified random sample. Now it's usually superior to simple random sample and stratified random sampling. The population is divided into strata that are believed to be relevant to variable. So here we have moved everyone into strata. We have male and female. So we might suspect that men and women might differ in opinions. So let's say we want to survey opinions on alcohol consumption with students on a college campus, and we might stratify the population according to gender and then draw separately from each stratum at random. So we would draw a random sample of men and separately draw a random sample of women. So let's say that we did that and we sampled 10% of the population. We had 1,600 men and 2,000 women, and we drew out 160 men and 200 women. Now, if you notice, there are more women in the sample than men, which is appropriate because women are more numerous in the population. It's important to note you would not be stratifying in order to compare men with women. Rather, the purpose is to obtain a single sample of the college population that is representative in terms of gender. So in a stratified random sample, the benefits of randomization, the elimination of bias, has been retained. Now, in addition, we've gained the advantage of having appropriate proportions of men and women in the sample. So if our hunch was correct that men and women have differing opinions on alcohol consumption, we would increase the precision of the results by stratifying the sample. Now, we also can say that stratifying does not eliminate all sampling errors. For example, when we drew women at random, we may have obtained women who are not representative of all women on campus, and the same holds true for men. Now, one thing we could do for large scale studies, we could have multi-stage random sampling. So now in this technique, we could draw a sample of counties at random from all the counties in a state. So we have North Carolina. We can then draw a sample of counties at random from all the counties in the state. Or we can draw a sample of voting precincts at random from all the precincts in the counties which were previously selected. And then we would draw individual voters at random from all the precincts that were sampled. So we could first stratify the counties into rural, suburban, urban, and then separately draw counties at random from these three types. And that would ensure all three types of the counties were included. And one of the reasons that we might do that is because we might assume that rural, suburban, and urban voters all have differing views, political views. So we might want to look at it from that standpoint. We then could do a random cluster sample. And for use of a random cluster sampling, all members of a population must belong to a cluster. So maybe like an existing group. So all Boy Scouts belong to troops. In most high schools, all students belong to homeroom. So unlike simple random sampling, the way the individual drawn in cluster sampling, clusters are drawn. So if we're going to conduct a survey of Boy Scouts, for example, a researcher could draw a random sample of the troops, contact the leaders of the selected troop, and ask them to administer the questionnaires to all the members of the troops. Now, there are two advantages to random cluster sampling over the other two types of random sampling we've already discussed. First, there are fewer individuals for a researcher to contact. So we're not having to contact each one of the individual Boy Scouts. We're simply contacting the troop leader. Second, the degree of cooperation is likely to be greater if the troop leader asks the individual scouts to participate than if we, as researchers who do not know the Boy Scouts, ask them. Now, there is a disadvantage to random cluster sampling. For statistical reasons that are beyond this book and this course, the number of clusters are treated as sample size. So now this is not the number of participants, this is the number of clusters. So if we have 20 troops with 10 Boy Scouts in each, we would have obtained responses from 200 Boy Scouts. However, we have to report the sample size as 20, not as 200, because they are clusters. This is not individual, it is cluster sampling. So when using cluster sampling, it is desirable to use large numbers of clusters to overcome the disadvantage. Now, as you remember from section 3, random sampling creates sampling errors, and the inferential statistics that are described in this part of the book are designed to assess the impact of these errors on the results that we as researchers obtain when we use random sampling.